Hello there, welcome to new video of feature extraction in machine learning. We will be discussing about feature extraction with an example in our today's video. So what is feature extraction? Feature extraction is nothing but process of identifying or selecting the most important information or characteristics of data set. It means that we are going to select more information which is more important to us, which is more characteristics for us in our data set. It is like distilling or essential element. We are going to collect the essential element which is able to help us to simplify, to take the details of data so that we can able to more focus on that data set. That feature extraction is able to help us to overcome overfitting problem. What is overfitting problem? I have already discussed in my previous videos. I'll be showing that link in my uh, notes there or in the notes. And today we are going to see something about, as I told you up, there is an X and there is a Y. There are two data set which is available to us, and we have got an output which is available to us. This is our expected output. These are our data which are available to us, and we call this one as our overfitting because maximum number of data or expected output is coming in around the line with very complex. It becomes very data become more complex, and we need to make it very simple. So in order to, let's take an example. If I have got X and Y, two attribute, I have divided X and Y, I have divided and I have got this one. This is what a problem comes up. In order to overcome this one, we use principal component analyzing. What do you mean by that one? It's a part how to overcome the overfitting. It reduces. How it reduces is just the way you view the part. It's just the way you view the part. Now this is my line. These are all my data set available on this one. These are my data set available on this one. I've got X and Y, two attributes or two features available there. So how I able to see? If I see from this one, if I see from this way, I can only see this part, correct? So this becomes only one line. This is PC1, correct? The way you view your data set is more important to us. Then if I see from this way, it becomes my PC. If I draw a perpendicular line here, all these points will come here. This how much far, how much far, how much far, how much far, how much far. This becomes PC2. So this becomes PC1, this becomes P. So how do you identify PC1, PC2 or PCA1, PCA2? With the help of how do you view that part. Note, PC can be less than or equal to your attribute. If I have two attributes, it can be 1 or 2. It cannot be more. And PC1 should be orthogonal. Orthogonal means they are not dependent on each other. Both are independent. If one is X, the X goes like this, or the Y will be like this. Orthogonal means they are not dependent on each other. They are independent and their different values are totally different. And do remember, PC can be less than or equal to attribute. How do you view? PC can be viewed the way you view PC, and it is using overfitting. So we are going to solve this problem. How do you do this? With the help of a problem. Let's solve the problem, and I'll be telling you that this video will be long. Please bear with me. We are going to solve the problem step by step, and it's all mathematical calculations, correct? Let's move on to this one. First, we solve the problem, correct? We have a data set. We have got feature X1 and X2. As I told you, I've got two features. So I have written X1 and there is one value 4, 8, 13, 7. Another one is 11, 4, 5, 14. Now first step 1. What is the step 1? I have divided this problem into step. First one is calculate the mean of your X1 and X2, correct? So mean will be 1 by 4. How many values? 1, 2, 3, 4. That becomes 4 by 4 plus 8 plus 13 plus 7. 4 plus 8 plus 13 plus 7. That is becomes something about 12, 12 plus 13, 25, 27, 30, 32 by 4, it becomes 8, and this becomes 8.5, correct? And I have given you the direct answer. Then this is the maximum steps you can go. We have to get two data set with two futures, as we need to reduce to one. What does it mean? Now, if I have got, what does it mean? I am going to reduce my data set which is of 2 into 1. How we are going to do? With the help of PC1. And how we are going to do? We are going to solve the problem. First step is that we have to calculate the mean. What is x1 and x2? We have already gone in. Correct? We have got the feature and we have already got the mean of that value x1 and x2. Now we need to calculate the covariant matrix. We need to calculate the covariant matrix. This is my step 2. Do remember, this is my step 2. First we have got ordered paired. What is our ordered paired? We have got both x and x. So how many possible values? Let's take example. If I take x1, this is x2. How many possible values are? If I take y1 and y2, how many possible variants? Ordered paired means how many possible operations are there. So I have got x1, 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 x2, x2, x1, x2, 2. So if I have got y1, y1, y2, I'll get y1, y1, y2, sorry, y2, y1, and all those things. Correct? All 4 operations. Sorry. So we'll get this one. Now put this in a matrix. Covariant of x1, x1, covariant of x1, x2, covariant of x2, x1, covariant of x2, x1. This is covariant matrix we got it. How to calculate this? Then there is a formula for it. What is the formula? To calculate the covariant of this, 1 by n minus n. What is n? We have got 4 elements. That is 1, 2, 3, 4. 1, 2, 3, 4. 4 minus 1. Sigma k is equal to 1 to n. X 1k minus x bar, x 1k minus x bar. That is means 1k, one first element for x1 bar, 2 element for x2 bar. That is equal to 1 by n minus 1 sigma 1 by. If both are equal, then it becomes bar, x1 k1 bar. We will solve the problem and you will be able to know how to use this formula. Correct? Now first one, x1, we have got this formula. That is 4 minus 8, 8 minus 8, 13 minus 8, 7 minus 8. This is the formula, 4 minus 8, 8 minus 8, 8 minus 8 whole square. We have done it and we got 14. Correct? The first value we got. Now what is the second value we have got? Remember, we have got second one here, which is represented. So how we have got it? x1, x2, 1 by n minus 1. This is 1k. Then becomes, this is 2 means this becomes 2k. So this becomes 2k. So what will happen here? Now 4 minus 8, 11 minus 8.5. 4 minus 8, 4 minus 8. 11 minus 8. If it is third, this becomes x 3k minus x bar 3. So we are not using it, so cut it down. So this becomes this. Next part, 8 minus 8, then 4 minus 8.5. 4 minus 8.5. This becomes 13 minus 8, 13 minus 8, 13 minus 8. 5 minus 8, this one, this. And we all calculation, if we do it, we are getting minus 11. Correct? So you are convinced with x1, x2. Now let's move on to the other one. We have got this one, x1, x2. What is this? x2, x1. These both are same. Both are same. So move on to here. We have 2 and 3 and same. 3 will be minus 11. Correct? Also. Now let's move on to other slide. Now we have to go for covariant x2, x2. As we have gone for this only. So we have to go 11 minus 8.5. 4 minus 8.5, 5 minus 8.5, 14 minus 1 whole square. Correct? This. I've got 23. Now put, we have got x. Now we are putting these values in this one. We got this one. 14, as we have seen, this is 14. And this is 11. And this is also 11. And this is 23. So we put it this value. We got covariant x. So s value is 14 minus 11 or something like that. Now putting this slides here, we have calculated your data set, we have calculated mean, we have calculated X variance. Now step 3, what is step 3? We have done step 1, step 2, step 3, calculated eigenvalues for covariant matrix. Covariant matrix is this one. We have to calculate the eigenvalues. What is the formula for it? Deterministic S minus lambda into I is equal to 0. This is the formula for it. Please do remember, this is the formula for it. What is that? Deterministic X minus lambda I is equal to 0. We know S we have already got it, correct? I is identity matrix. So 14 minus 11, whatever is here, we brought it here. Minus lambda into this. Multiply this becomes lambda, 0, 0, lambda. And multiply both, we get 14 minus lambda, minus 11, 20. As is equal to 0, we put it here. Now cross multiplication, what is the value? Got it? Lambda square minus 37 lambda plus 201. Correct? Let me move on to this slide. We got lambda minus this one. Correct? Now we will get two values. How? Because it's a quadratic equation, a square minus a square b square plus 2ab, something like that, or it is a square, a quadratic equation, which is given by the formula is to find out the root 1 by 2a plus b plus or minus square root of b square minus 4ac. So we have got, this is b, this is c, and 1 is our a. So 1 by 2a into 37 square by this one, we calculated, we got one value as 13.1, other value is 6.0. We took them as lambda. I hope we are clear up to this point. So what are the values we got it? We got lambda 1 and lambda 2. Now let's move on to other part. Step 4. So we have got this one, step 1, we have got step 2, we have got step 3. We have got two values, lambda. Now step 4, what is this? We have calculated eigenvalues for our S. Now we need to compute eigenvectors. This is eigenvalues. We need to compute eigenvectors. We given them as mu, u, u1, u2, and the equation will be same. What is the equation for eigenvalues here? It is deterministic S minus lambda 1. What is the eigenvectors? What is this? For the eigenvectors, it is no deterministic S minus lambda 1 or lambda I, this one, mu equal to 0. So we have got S values, correct? We have already got S, or we have already got this values, we have already got this values into mu, whatever the value is, that we are equal to 0. Now multiply this one inside, because it's 4 into 2 matrix. We got lambda into mu 1 minus this one into this one. We have got this one. Now we have got this one, lambda 4 minus lambda mu 1 minus 11 mu 2, 11 mu 1 plus 23 minus lambda equal to. Now solving this equation. What is this? We have already got this equation, correct? Equal to 2. First equation I have taken into consideration. I have taken first equation into consideration, correct? I have taken first equation, this equation too. So lambda 14 minus lambda mu 1 is equal to this one. This lambda will go this one. This become, what is minus lambda is equal to this one. Mu 1 and this mu 2 come down. 11 by this. Let make it equal to t. Let make it equal to t. Now solving, mu is equal to t and mu 2 is equal to this. Assuming t is equal to 1, we got mu is this one and mu 2 is this one. So what is the value of mu? Solving only one equation, we have not taken it very serious. So what is the value of eigenvectors? We have got 11 plus lambda minus 1 in a matrix format. So we have got this one, correct? Step 6, the same we have to calculate. Now based on this one, we have to calculate something. What is this? Step 6. We need to compute the unit eigenvector, the distance of eigenvectors. We have got this one, 11 minus lambda. We have got unit eigenvectors. Now you have to calculate unit of eigenvectors. Imagine we are just going to get only 1 point for this one, correct? Now Let's take an example. We have to take the largest lambda value. What is the largest value we have to take? We have already got lambda value, that is 30. 11. How do you get it? This is by, let's take an example, a b mu square root of a square plus b square. Correct? This is eigenvector. So this becomes the whole square. This becomes the whole square. What is the lambda value? Lambda we have taken at this one, 30 square. So this becomes 30. Now we need to get E1. E1 is mu by this bar. Mu is what? 11. 11 by, what is this? 19.5. What is this? 11. Whatever, 14 minus 30. Lambda by this one. This by, what is the value we got? We got it this one. Correct? Now, this values we have already got it. Now, if I put the second value 6, we are not bothered about E2, we are only bothered about E1. If I put E2 here, then E2 will be, this one will become 6.6151, and this value differ, and here the value differ. So E2 will get you about this values, that is 0.83. We are only bothered about this point. How to get this one? Sorry, how to get this one? We have to calculate eigenvectors. How to get eigenvectors? First we have to calculate covariant matrix. After covariant matrix, in this matrix we have to get, eigenvalues. First we have to calculate eigenvalues. Once we got the eigenvalues, then we have to go to eigenvectors. Once we got the eigenvectors, we got E1. Correct? Now compute the principal mark. Step 6. We have already got mean as lambda 1, lambda 2. Now we have already taken E1. We are not bothered about E2. We'll see later on how it's going to happen. Correct? Now we are going to see about this one. E1 transport x1k, this x2k, this one. Now what is E? We have already got it. Into transport means it becomes like this, 0.5574 minus like this. Correct? It's already there. We have got this one into I1k minus x bar, x2k bar, x1. Now take this one, multiplication for this one multiplied by this one. This become into this, this into this, this into this. Correct? This, what is x11? 4. What is x bar? 8. Correct? Now this one, x21, this is, what is this? 11 minus 8.5. This is for one value. I've got 4.3. Correct? I've got 4.3. Now the second values it becomes 8 minus 8 and 8 minus 8. This becomes 4 minus 8 point. Third values 13 minus 8 and this becomes 5 minus 8. And fourth value 7 minus 8, this becomes. The first value I have calculated. What I have calculated? 0.11 into this one and this one into this one. 0.11 is that 4. This becomes 4. This is 4 x11 and this becomes x bar. This is 8 and this becomes 11 and this becomes 8.5. So based on this value, if I calculate it, I'll get 4.2. Sorry. Now let's move on to other one. Look, I've got this one. Now we have calculated this one. First value I have calculated 4 minus 4.3. Correct? The second value, if I put 8 and 4, this is 8 and 4, what will be the value? Because 8 and 4, if I put, I'm getting 3.6. Now if I put 13 and 5 in this value, what I am getting? I am getting 5. And what I am done? I have taken x1, x2 and converted into 1. So your data is complex, you made it first principal component EP1. Now how do you do in this one? Let's take example. I have already drawn this graph. Correct? This is 2, 4. This is our previous point, 4 and 11. These are all. Now this is our, what do you call, x bar. What is this? X bar, 8 and 8.5. Correct? And what is our E values? If I take this as 0, 0, let me go with the pen. Yes. If I get 0 0, if I get 0 0, first one, and it's here because it's coming 0.5 and 0.8. So it's, sorry, it's here. So I draw the line here. This is my line. It is coming here. So it is going through this point. So this is my E1. Now, if you turn this one, this becomes 0 0. And if it is a straight line, if I put this one, if it is 0 0, where the next point is -4. So if I put it 0, -4 is coming here, this point. 3 plus 3 plus 3 will come here, -4. If it is 0 0, -3, it will plus 4. And the next point is 5 will come up here, 5, because it's a straight line, it will come up here, 6. So what we have done, it we have made this two into one line. And if I go for E2, let's take an example. What is my E2? Sorry, what is my E2? It will be here. Yes, 0.8 and 0.53. 0.8 and it should be here. So my E2 will be coming like this. If you see it, it is my E2, perpendicular to each other. This is how we divide our first principal component. So what are the points? Please keep it. It's very important. Don't get confused how to calculate this one. What is how it is used? It is used in overfitting, and it is to reduce all those things. And it is one thing. Let me revise. First we have to calculate it mean. Second we have to calculate it covariance, correct? And with the help of with the help of ordered paired. Third we have to calculate it same as we have done it with the formula. Then the formula is this one, correct? The formula is this one. And then third we have to calculate eigenvalues with the formula this. We have already know S. So with this one, and then quadratic equation we get lambda 1 and lambda 2. Then based on that one we calculate eigenvectors. What is that? Mu is equal to V1. We have already with the formula like this, correct? And then we are using only first equation. Do remember, we are using only first equation. Then we have already got these values. If you now what we have to submit? We have to submit eigenvectors. How do you do? With the formula which is available. I got this one and E2, and we have then compute principal component. It is given by E transport for this one which we have calculated, and we have so. I hope you have already seen it. Thank you very much. If you like the video, please click like button. Thank you very much.